Welcome. In this video lesson, we are going to understand about similar figures. Then precisely we enter into similar triangles. Now, so many different similar figures are kept in front of you. Yes, squares are there and square of side increased and diminished, so many. So if you take any square, whatever the side it has, all will be similar. Similarly, equilateral triangle, all equilateral triangles are similar. Similarly, if you see any circle of any radius, all circles are similar. So now we got a polygon, quadrilateral, and here two quadrilaterals are seen to be similar. So by seeing regular polygons, squares like equilateral triangles, regular pentagon, regular hexagons will be similar. But what will be the definition which polygons will be similar? So any two polygons will be similar if their corresponding sides are in same ratio and corresponding angles are equal. Corresponding sides are in same ratio, corresponding angles are equal. Moreover, if you are two similar figures, if one figure is increased with all the dimensions, it overlaps the another. When it happens, it's two similar figures. They are similar figures, otherwise they are not similar. So definition for this will be: two polygons of same number of sides are similar if corresponding angles are equal, corresponding sides are in same ratio. So now if you want any similar figure out of like this experiment shows that a quadrilateral here and its shadows, they are similar. The size of the shadow is increased here. So in this way, these two figures are similar. How? If you see the ratio of each and every side, 2.4 and 4.8, that is exactly, if you divide, you'll get a ratio 1 by 2. 2.5 by 5, 1 by 2. 1.5 divided by 3, 1 by 2. 2.1 divided by 4.2, 1 by 2. Everywhere the sides, corresponding sides are in same ratio and all the corresponding angles are equal. So these two figures, according to the definition, any two polygons of same number of sides are similar if the corresponding sides are in same ratio, corresponding angles are equal, so they are similar. So here, if you keenly observe, these two figures are not similar. And if you are keenly observing, all angles are 90, all angles are 90 degree, here also, but they are not similar. Why? Because the ratio of these two sides is 3 divided by 3.5, which is something else, and the ratio of the other sides is 3 by 3, 1. So corresponding sides are not in the same ratio. Therefore, these two triangles are, these two figures are not similar. So if you keenly observe, all the sides are in same ratio, but angles are different. Here all the angles are 90 degree, but here if you keenly observe, the angles are greater or less than 90 degrees. So these two figures are not similar in respect of the sides are in same ratio. Two polygons will be similar if the corresponding sides are same ratio and the corresponding angles are equal. So with this knowledge, whether we are able to answer the exercise 6.1, let us see. All circles are similar, yes. All squares are, yes, similar. All dashed triangles are similar, equilateral triangle. Two polygons of the same number of sides are similar if the corresponding angles are equal and their corresponding sides are proportional. Same ratio means proportion. Given two different example of pair of similar figures, non-similar figures. So two similar figures, if you want, the photograph of yours passport size and the little bit bigger one is similar, and non-similar figure. So the many non-similar figures you come across, Your mobile phone, your telephone, they are not similar. Your mobile phone and laptop, they are different. They are not similar. For example, if you are having an isosceles triangle here, isosceles triangle with different angles, they are not similar. So in this way, exercise 6.1 we have completed. So if you see, keenly observe, state whether the following quadrilaterals are similar or not. So continuation of this exercise problem, sorry, not completed, but by this we may complete. So these two quadrilaterals are not similar. Why? Because the sides are in same ratio, good, but the angles are different. Now precisely let us take this similar topic, similar figure topic for the triangles. Two triangles, triangle is also polygon. The two triangles are similar if their corresponding sides are in same ratio and corresponding angles are equal. When mathematicians go deeper into deeper and they bring the minimum criterions by which we can conclude the two triangles are similar, those are discussed in Similarity Criterion for the triangles. I hope you understood this exercise, introduction exercise. So let us precisely learn more similar criterions as well as basic proportionality theorem in the coming video lesson. Thank you very much. Welcome. In this video lesson, we are learning basic proportionality theorem. It's also called as Thales theorem. If a line is drawn, if you keenly observe the diagram here, so in this diagram, in a triangle, if a line is drawn, DE is a line drawn according to the statement parallel to one side of a triangle. This line is parallel to one side of a triangle like this. To intersect the other two sides, it is intersecting other two sides in the two distinct points D and E. Okay, the other two sides are divided in same ratio. It means that AD by DB is equal to AE by EC. The theorem conclusion tells that. So according to the theorem, AD by DB is equal to AE by EC. We need to prove this, and let us keep that particular result as the formula. That is basic proportionality theorem. Are you ready to understand the proof of it? Yes, let's go to. So here required to prove is AD by DB is equal to AE by EC. In order to do that, we need to do some construction. So drawing perpendicular altitudes DM and EN joining DC and BE we are doing. Then how to do the proof, how to get to the proof result. In order to do that, we need to analyze first. First of all, analyzing that how can I get a ratio AD by DB and AE by EC. So AD by DB is the ratio. If we want, we are thinking over finding the area of triangle ADE and area of triangle BDE. Then if we are cancelling the similar terms, equal terms, then what will be left out? AD by DB. So then similarly we can do on the right side also AE by EC. Whether we are able to prove that AD by DB is equal to AE by EC analytically, let us see. So from figure, area of triangle ADE is equal to half into base into height. Height is EN. Similarly, area of triangle BDE, half into base, this is my base, and height is EN only. When we write these two statements and divide, area of ADE divided by area of BDE is equal to half into, here when we write these two statements, EN, half of it can cancel, AD by BD is left out. Okay. Similarly, if we are writing the same statement for this triangle area ADE and DEC, taking base AE and base for this below triangle EC, half into base into height, height will be DM. So you will get the statement like this. DM, half of will get cancelled, left out with only AE by EC. Now keenly observe that, come to the figure, triangle BDE and CDE, these two triangles are in such a way they are having common base DE and they are between same parallel lines. There is a theorem in the 9th class that triangles having same base and between same parallel lines are equal in area. Therefore the triangle BDE and DE area will be equal. So we got these triangles having same base and between same parallel lines will have equal area. So now if we keenly observe equation 1, 2 and 3, the numerators ADE areas are equal. The denominator BDE and CDE, just we prove that they are equal. So complete numerators and denominators are equal. It means that equation 1 and 2 are equal. That is AD by BD is equal to AE by EC. Hence we prove the basic proportionality theorem. Now this result can be used to get the solutions of many problems. I hope you understood the theorem and the proof. Thank you very much. Welcome. In this video lesson we are going to learn converse of basic proportionality theorem and its proof. Let us understand the statement. If a line divides any two sides of a triangle in the same ratio, in a triangle ABC, there is a line which divides the two sides in the same ratio, that is AD by DB is equal to AE by EC. It is given in the statement. Then the line is parallel to the third side. The theorem tells that this DE is parallel to BC. Let us prove this. So given is AD by DB is equal to AE by EC. We need to prove DE is parallel to BC. Let us construct and think over, if DE is not parallel to BC, there must be any line another which will be parallel to BC. So draw a line DE dash parallel to BC. So this is DE dash parallel to BC. Proof: in this triangle ABC, as DE dash is parallel to BC, by basic proportionality theorem we can write AD by DB is equal to A E dash by E dash C. That is basic proportionality theorem tells us this. But already given that the AD by DB is equal to AE by AC, from these two statements we can write they both are equal. In order to show that E dash and E are both the same points, adding one on both sides, that will bring AE dash plus E dash C by E dash C is equal to AE plus EC by EC. That is AE dash plus E dash C. If we see in the diagram, that is AE dash plus E dash C and AE plus EC is the same line AC. So numerators you will get as AC by AC. We can cancel from that. We can prove that E dash C is equal to EC. That is E and E dash must coincide and they must be the same lines. DE and DE dash are same lines, hence DE is parallel to BC. This is the converse of basic proportionality theorem, may be asked in exam in 2 marks or 3 marks. So hope you understood. Let us take some problems on basic proportionality theorem and as well as converse of basic proportionality theorem in coming video lessons. Thank you very much. So as discussed in the in this triangle we need to find x. In triangle ABC, this DE is parallel to BC given, so we have written. So whenever we are having a line parallel to the one side of the triangle, by basic proportionality theorem the ratios are equal. AD by DB is equal to AE by EC. So when we substitute the values, we can get this EC, which is written as x by cross multiplying, simplifying, getting x value. We got x2. Similar question is here. Here we need to find AD. Same ditto copy. Theory is there. D is parallel to BC and basic proportionality theorem. So ratios will be equal. When we write the ratios, only one unknown is there, AD. So cross multiplying to get the answer. Let us go to the next question. In the next question, what it is asked? In this triangle EF are the 2 points on side PQ and PR respectively of triangle PQR. For each of the following case, that is 1, 2, 3 cases are there, state whether EF is parallel to QR. So now what we have to see, we have to check for the converse of basic proportionality theorem whether the ratios are equal or not. So if we are seeing in this triangle PQR, PE by EQ is the ratio 3.9 by 3. When we cancel, we got it 13 by 10. PF by FR, when we got 3.6 by 2.4. When we cancel 3 by 2. So PE by EQ is not equal to PF by FR. Hence, this EF is not parallel to QR. If the ratios are equal, then we can say they are parallel, EF and QR. So you can try for these two questions. Let us go to the next question. Question is written here in figure 6.18. Okay, this is LM is parallel to CB Okay, ln is parallel to CD. Prove that am by AB is equal to an by AD. So yes, the lines are parallel. Then from the basic proportionality theorem we will get am by MB is equal to AL by LC, but he is asking am by AB, a full side. Whenever for the basic proportionality theorem we will get am by MB, in order to make a full side we have a technique adding 1, and let us see how to do it. Let us look to the solution. Given is LM is parallel to CB and L is parallel to CD. Required to prove is AM by AB is equal to AN by AD. In triangle ABC, if we consider this line is parallel to this line, by basic proportionality theorem we will write AM by MB is equal to AL by LC. Similarly, in triangle ADC, NL is parallel to CD implies AN by ND is equal to AL by LC. From these two equations we can conclude that AM by MB is equal to AN by ND, but this is not the solution, but we want AM by AB, the full side which is in denominator, and we already know that the something we can increase, it will be in the numerator. So how can we increase reciprocally? First of all, reciprocally, so it implies MB by AM is equal to ND by AN. Then adding 1 on both sides, it will give MB by AM plus 1 ND by AN plus 1. When we do the simplification, MB plus AM divided by AM is equal to ND plus AN divided by AN. So when we see the diagram, what is going to be MB plus AM? Please see here the diagram. MB plus AM is AB. Similarly, AN plus ND will be AD. We can write that AB by AM here and AD by AN. So again reciprocally on implies AN by AB is equal to AN by AD. Hence we got the solution. Let us look to the next question. Here is the question. In figure, if LM is parallel to CB, LM is parallel to, welcome. Here comes fourth question. In figure, DE is parallel to AC, DE is parallel to AC, DF is parallel to AE, DF is parallel to E. Prove that BF by FE is equal to BE by EC. How to do this problem? Whenever we are doing problems of analytical mathematics, geometry, like, we need to get the answer first of all in our analysis, thinking. So let us orally discuss, and what we discuss, let us write that. In triangle ABE, what is given here? DF is parallel to AE. That implies by basic proportionality theorem, BF by FE is equal to BD by DA. Keep it as equation number 1. Then in triangle ABC, DE is parallel to AC. That implies by basic proportionality theorem that BE by EC is equal to BD by DA. Already BF by FE is equal to BD by DA. Now BE by EC is equal to BD by DA. It means that from equation 1 and 2, BF by FE is equal to BE by EC. What we just told with our tongue, let us write that. Here is the solution. In this triangle ABE, DF is parallel to AE. So by basic proportionality theorem, BF by FE is equal to BD by DA. Let us keep equation number 1. In triangle ABC, DE is parallel to AC. Implies that BE by AC is equal to BD by DA. From these two equations, both are equal to BD by DA. So in BF by F is equal to BE by EC. Hence the solution. So hope you understood. Let's go to another question. Next question is here. If we understand the previous, we can easily do this answer. So orally, if you want to discuss Let us. DE is parallel to OQ in this figure. DE is parallel to OQ. So in triangle POQ we can apply basic proportionality theorem. DF is parallel to OR. DF is parallel to OR. Again in this triangle basic proportionality theorem can be applied. And if we apply in this triangle POQ, PE by EQ is equal to PD by DO. Similarly, in triangle POR, PD by DO is equal to PF by FR. In this equation, two equations, the ratios are equal to PD by DO. It means that PE by EQ is equal to PF by FR. In triangle PQR, these ratios are equal. It applies by converse of basic proportionality theorem. EF is parallel to QR. What we said, let us write that. Let us see the solution. Given ED is parallel to OQ and EF is parallel to OR, we require to prove is EF is parallel to QR. In triangle POQ, written here, ED is parallel to OQ by basic proportionality theorem. In triangle POQ, PD by DO is equal to PE by EQ. It is written here. That is equation number 1. Similarly, when we apply DF is parallel to OR and basic proportionality theorem is applied, PD by DO is equal to PF by FR. These two equations gives us PE by EQ is equal to PF by FR. Now in triangle PQR, if you see PE by EQ is equal to PF by FR, it means EF is parallel to QR by converse of basic proportionality theorem. Hence, we got the solution. Let us see the next question. Yes, again with the same technique, we will be able to solve this. I hope you are tuned with this lecture. Let us discuss this question orally. In this figure, A, B, C are the points on OP, OQ and OR such a way that AB is parallel to PQ, AC is parallel to PR. We need to prove BC is parallel to QR. Ditto question which is solved just. Okay, no problem. Let us discuss orally. In triangle POQ, as AB is parallel to PQ, by basic proportionality theorem, OA by AP is equal to OB by BA. Keep it is equation number 1. In triangle POR, AC is parallel to PR implies by basic proportionality theorem, OA by AP is equal to OC by CR. Keep it equation number 2. As we compare equation 1 and 2, what happens? They both are equal. That implies OB by BQ is equal to OC by CR. Let us see this question in written mode. So in written part, given in figure, AB is parallel to PQ and AC is parallel to PR. If you see, keenly observe the in triangle POQ, AB is parallel to PQ implies by basic proportionality theorem, OA by AP is equal to OB by BQ. Normally we make a mistake by writing OA by AP is equal to BQ, B by BO. That's wrong. Starting with O, then we have to write OA by AP, OB by BQ. Okay, let us take come equation number 1. In triangle POR now, AC is parallel to PR implies again by basic proportionality theorem, OA by AP is equal to OC by CR. That is my equation number 2. If we compare these two equations, what is going to happen? OB by BQ, OB by BQ is equal to OC by CR. OB by BQ is equal to OC by CR. By converse of basic proportionality theorem, when these ratios are equal, this line which makes the ratio same is parallel to third side. BC is parallel to Q1. That's the proof. Let us see the next question. That's a 9th question. Let us draw the diagram for this. Here is the diagram. He told that ABCD is a trapezium, AB is parallel to CD, and diagonals intersect at O. We need to prove AO by BO is equal to CO by DO. This can be done with two methods. One is by drawing a parallel line from this like this. So we can prove which we have done in example problem. And also there is another method which is used by similarity criterions, that can be done by similarity criterions. So let us do this problem by understanding similarity criterions. AAA similarity criterion, SAS similarity, triple S similarity criterions. And let us come to this problem. We'll enjoy the coming exercise if we are understanding the similarity criterions. Thank you very much. Let us understand similarity criterions in the next video lesson. Welcome. In this video lesson we are learning similarity criterions. So if we are having two triangles in such a way that triangle ABC and triangle DEF, their corresponding angles are equal, means here, for example, here this angle and this angle is equal, angle B and angle E, two slashes angles are equal, and this angle C and angle F is equal. Therefore, when two triangles are having corresponding angles equal, when we say these two triangles ABC is similar to triangle DEF by AAA similarity criterion. In short, if we have been not given only third angle, just two angles are given, then also automatically third angle will be equal. If two angles are equal, third angle automatically will be equal, because angle sum property, if we are using, the third angle will become equal, and we will be using triple A similarity criterions. Otherwise, just AA similarity criterion is also helpful to you prove these two triangles are similar. That is, if one triangle corresponding two angles are equal to another triangle, then these two triangles are similar by AA similarity criterion. Triple A or otherwise just AA whole square. Let us understand the next similarity criterion. Here is a triple S similarity criterion. If in two triangles sides of one triangle are proportional to, that is in the same ratio, the side of other triangle, then these corresponding angles are equal, and hence the two triangles are similar. Or directly just we can tell these two triangles are similar. How this is in triangle ABC and triangle PQR. We are not proving this statement and theorem, we are how to use this theorem we are learning. So in triangle ABC and triangle PQR, AB is given as 3, AC is 4, here BC is 5, in this triangle this one. We have to make up ratios. AB by PQ is how much? 3 by 1.5, we got it 2. BC by QR is again 2. AC by PR is again 2. We need to prove that these all ratios are same, equal. When these corresponding sides ratios are equal, then these two triangles are similar by triple S similarity criterion. So in this similar way, we have another similarity criterion. Now let us discuss this theorem. If one angle of a triangle is equal to one angle of the other triangle, okay, here one angle and one angle, two corresponding angles are equal, and the sides including these angles are proportional, means this angle is made by these two sides, this angle is made by these two sides, and these two sides are proportional, then the two triangles are similar. How to write this? Considering this example, two angles are equal, 69, corresponding here the including sides, 4 is here 2, here is 5, here is 2.5. We keenly observe that the sides are becoming half, or from here to here is becoming double. So in triangle this and this, two angles are equal, and AB by PQ, the ratio is 2, AC by PR, again the ratio is 2. It means that these two ratios are equal, they are proportional, their ratios are same. It means these two triangles are similar by SAS similarity criterion. So I hope that you understood triple A similarity criterion, you understood from that double A similarity criterion, we understood triple S similarity criterion, where all the corresponding sides are in same ratio, but here two sides are in same ratio with including angle, or including angle with including sides are in same ratio, that is SAS similarity criterion. I hope this will ease enough and will make us understand the coming exercise very nicely. Let's enjoy solving the problems. Thank you very much. Welcome. Let us take some questions on similarity criterion. The question is ready. If PQ is parallel to RS, these two lines are parallel, prove that triangle POQ, SOR are similar. Yes, If I am able to prove that two angles of one triangle is equal to another triangle, then these two triangles will be similar by AA similarity criterion. So my intention is to check for angles first. If angles information I am not getting, then I will go for SAS similarity criterion or SSS similarity criterion. The basic information very easy is to use AA. So one angle I got, this angle is equal to this angle, vertically opposite angles, and this angle is equal to this angle, alternate interior angles. Similarly, these two angles are also equal because alternate interior angles are equal. I was searching for two angles, I got three angles of one triangle is similar to another, equal to another triangle. Correspondingly, these two triangles are similar. This is the way. By thinking, we have to get the answer. Now, whatever we told, whatever we analyzed, that we have to write now. Here is the solution. Given in the figure, PQ is parallel to RS. Required to prove is triangle POQ is similar to triangle SOR. Whenever we want to prove these two triangles similar, then take these two triangles. Angle POQ is equal to angle SOR because vertically opposite angles are equal. Similarly, angle PQO is equal to SRO, vertical alternate interior angles are equal because these two lines are parallel, and angle QPO is equal to angle RSO, again alternate interior angles are equal. This gives that three corresponding angles of one triangle is similar, equal to another triangle, implies these two triangles are similar by AA similarity criterion. Hope you understood this. Let us take the next question. Yes, here the question is there, which is given here: OA times OB is equal to OC times OD, and angle A is equal to angle C. We have to prove that angle A is equal to angle C and angle B is equal to angle D. Angle A is equal to angle C, angle B is equal to angle D. Yes, if I am able to prove these two triangles similar, then corresponding angles will become equal, then my answer goes correct. What is given here is the ratio. OA, OB, OC, OD. If I just make arrangement, it will become OA by OC is equal to OD by OB. Then what happens here? These two triangles, two corresponding sides will become in same ratio, and including angle is vertically opposite angle, which is equal. These two triangles will be similar by SAS similarity criterion. Then I can write, if two triangles are similar, their corresponding angles are equal, then I'll get the solution. What we discussed, let us write. Now what we discussed, we are writing. Given is written. Whatever given was there, we have reshuffled to get the corresponding sides ratio. So we got AO by OC, OD by OB. Okay, angle A is equal to angle C, angle B is equal to angle D. We need to prove in triangle AOD and COB, it is by mistakenly written here COB. AO by OC is equal to OD by OB, which is given. Angle AOD is equal to angle COB because of vertically opposite angles are equal, and this vertically opposite angle is also the including angle of these two sides. That is why these two triangles are similar by SAS similarity criterion, and when these two triangles are similar, the corresponding angles are equal. So angle A and angle C is corresponding. Angle B and angle D are corresponding angles are equal. Hence the solution. A girl of height 90 cm is walking away from the base of lamp post at a speed of 1.2 meters per second. It means the girl was standing here. She is moving in this side with a speed of 1.2 meters per second. So in 1 second she moves 1.2 meters in how many seconds? If the lamp is 3.6, okay, so find the length of her shadow after 4 seconds. So after 4 seconds she moves 4 times 1.2 meters, that is 4.8 meters. So this distance from here to here is 4.8 meters. We want the shadow of the girl. Yes, a girl of height 90. So when this type of question comes, there is two right angle triangles, and here two right angle triangles are similar. How? Because this angle in this right angle triangle and this big triangle ABE is common, and whenever we are talking about poles and people walking, they are perpendicular to the ground, so 90 degree. These two triangles are similar by AA similarity criterion. Then by that Cbse, if we use corresponding sides will be in same ratio, then we can find the answer. So let us see how I'm writing. Here, as she is moving 1.2 meters per second, it means in 1 second 1.2 meters, in 4 seconds 4 times 1.2, that is 4.8 meters. Convert into centimeters because the height is one information is given in centimeters. So this is, I want everything in centimeters. So in triangle CDE and triangle ABE, these two triangles are similar by AA similarity criterion. How? This angle is common and this is 90, this is 90 is written here. These two triangles are similar, and by CPST corresponding sides will be in same ratio. We need to take those sides ratio in which information of the sides is given. So we are not taking about AC and CE, AE. We are not taking that ratio because the information of that is not given. Therefore, when we write CD by AB is equal to DE by BE, from here corresponding sides will be in same ratio. Substituted, cancel to get the answer. 160 centimeter will be the answer. I hope you understood. Let us take next question. Here is a question. In figure, okay, CM and RN are respectively the medians of triangle ABC and triangle PQR. Okay, so prove that triangle A, and given that triangle ABC is similar to triangle PQR. Okay, prove that AMC triangle and PNR triangle are similar. Then this CM by CM by RN is equal to AB by PQ. Okay, same ratio, and similarly we need to prove this. How can we do that? Yes, whenever we are doing the problem, let us do orally first, then loud. If we are talking about triangle AMC and triangle PNR, if we want to prove this, whether I am able to prove with the help of AA similarity criterion, check it out for that. So when we are having AMC, PNR, actually they are medians. Angle A is equal to angle B. Yes, this one angle we got equal, another angle we are not getting. So try for SAS then. So this bigger side ratios are in proportion because the two triangles are similar, and we can apply. If we are having two sides ratios are same, both them will also have the same ratio. AB by PQ will be equal to AM by PN because AM is half of AB, PN is half of PQ. From that we'll get SAS, similarity criterion can be used. So see how the solution is obtained. Let us understand the solution for this. Now, what is given? Triangle ABC is similar to triangle PQR. When the two triangles are similar, by CPST we can write the corresponding angles are equal and corresponding sides are in same ratio. Also given that CM and RN is median. Now we are proving the first bit of this question. In triangle AMC, triangle AMC is similar to triangle PNR. So we here keenly observed SAS similarity criterion will work. As given the ratio AB by PQ is equal to AC by PR, half AB will be equal to half PQ. Whenever medians are given, this ratio will work. Half AB is AM, half PQ is PN if you keenly observe half AB is AM, half PQ is PM. So this ratio we got from that. Angle CAM is equal to RPN already given. That's why these two triangles are congruent, similar by SAS similarity criterion. By CPST we can write this ratio from this. CM by RN is equal to AC by PR, but AC by PR is already equal to AB by PQ, which is given in the written in the given. Therefore we can conclude this. That is second bit also completed. Now let us see what is difference between first bit and third bit. Here triangle AMC and triangle PNR is given. In the third bit, angle triangle CMB and RNQ is given. It means just whatever we have used to prove triangle AMC is similar to PNR, we can use here the similar manner. So try for that. I hope you understood. Just we have to write the ratios. MB by Rn is equal to BC by QR, prove it, and angle B is equal to angle Q, which is given. These two triangles are similar by SAS similarity criterion. Okay, let us take in another. Yes, we have completed example problems. With these example problems, we will be able to solve exercise 6.3, where the problems will be given to us to solve with the help of similarity criterions. Moreover, if some case we are able to solve the problem with the help of basic proportionality theorem, let us do that also. Thank you very much. Let us meet in next video lesson where we are solving exercise problems. Welcome. Here is your exercise 6.3. State which pair of triangles in these figures are similar. Write the similarity criterion used by you for answering the questions, and also write the pair of similar triangles in the symbolic form. Let us do that. Here is the first question, first bit. Triangle ABC, triangle PQR, okay. Here one angle is 60, good. 80, good. 40, yes. These two triangles are similar, so they are similar. Triangle ABC, similar triangle PQR. Cross check whether A and P are equal, yes. B and Q are equal, yes. C and R are equal, yes. Triangle are similar by ASS similarity criterion. Let's go to bit number 2. So with triangle ABC, triangle PQR, cross check. This is 3 and we got this as 6, okay, exactly double. This is 2.5, we got a double of 2.55, and here we got 2, here we got 4. So all the sides are in the same ratio, but the order is very important. So let us write the order. In triangle ABC, and see here, when we are having the triangles ABC and we cross check, each and every side is doubling to get that, but the order we need to understand. Triangle ABC and triangle QRP. How ABC, if I am taking, as we are moving from ABC, a 2 centimeter side to 2.5 centimeter side, its corresponding in this triangle will be 4 and 5. So we have to go from 4 to 5 because proportional side is here 4, 2.5 proportional side is 5, so we have to move from in this way QRP. So triangle ABC is similar to triangle QRP will be the answer. Let us take next one. We got a triangle, again third question, LMNDEF. Okay, 2's corresponding, it can be 4, 3's corresponding can be 6 because it's a double. 2 also, 2 sides are in same proportion. But 2.7's double will be 5.4. We are having only 5. These two triangles are not similar because the sides are not in the same ratio. Let us discuss this question here. Fourth one, 2.5, exactly double or triple sometimes. If we are doing again, okay, correct, sorry. 5 I am having an exactly double of 5 is 10, so they can be corresponding. Now the including side of these two is 70 angle. Yes, it's correct. So these two triangles are similar by SAS similarity criterion. So let us, so which triangle? So if these two triangles are not similar, let us write the names of this triangle. Triangle NML NML is similar to triangle. So writing in order is very important. NM, I am going from 2.5 to 5. So we have to go from here like this. Here PQR, side is P. So P5, 2.5 corresponding side to angle, then corresponding side of 5. NML 2.5 M. So PQR by SAS criterion. Yes. Let us take another one. Yes, in this triangle we got a two sides, but including angle is not 80. It is some other angle. Here the two sides are there, including angle is 80. So these two triangles are not similar because SAS similarity criterion is not fit here, because two sides including angle must be equal. As we got a two sides here, including angle is given 80, but here this is not including angle. Including angle is this one. So these two triangles are not similar. If you check here, one angle is 70, one angle is 80. If you cross check here 80 and 30, if we apply angle sum property, 80 plus 70 is 150. If I subtract from 180, I'll get this as 30. Yes, if you now check it out, 80 and 30, yes, two angles are similar. It means that these two triangles are similar by AA similarity criterion. Yes. So I hope you understood. Let us take some more questions. We got a question in figure 6.35. As we are doing this is exercise problem orally, if I explain, you please try to do this, or otherwise if after the explanation I'll show my answer. In figure 6.35 means this is a figure. Triangle ODC, ODC is similar to triangle OBA, and this is information angles are given. We have to find angle DOC and DCOAB. All the angles we can find, because already these two triangles are similar. We can apply CPST. Here we need to find angle DOC, DCO and OAB. We have to use all our basics and similarity criterion, CPST also. Corresponding parts of similar triangles will be used here. Now in figure, when we are finding DOC angle, if we keenly observe DOC and COP, they are linear pair, means they are straight, making a straight line. If we add, we have to get 180. That property we can use and find DOC. So simple to find this one. So we bought this angle DOC with linear pair. Then angle DCO by angle sum property also you can find, or otherwise you can find with the help of external angle property of the triangle. So we found by external angle property, we got that as 55, and okay, angle DOC also 55 we got with the help of angle sum, linear pair. Now angle OAB is equal to angle DCO. Why we got it? Because as we proved that ODC is triangle similar to triangle OBA, by CPST we got these two angles equal, so we got that as 55 from equation number 1. Hence let us take another question. So we got a question here. What does the question tell? Diagonals AC and BD of a trapezium ABCD with AB parallel DC intersect each other at point O. Using similarity criterion for two triangles, show that these two OA by OC is equal to OB by OD. Let us do this diagram first. For this question, this will be the diagram. AB and CD are parallel. Moreover, the diagonals intersect at point O. We need to prove that OA by OC, OA by OC is equal to OB by OD. If we keenly observe, these are becoming the sides of the triangle AOB and COD. Whether if I am able to prove these two triangles are similar, then my problem is completed. By CPST I can write that ratio. So whenever he tells us to prove the ratio, please check it out whether this ratio forms what angle and what triangles, and whether I am able to prove these two triangles similar. So if I keenly observe, I got these two triangles can be proven similar. By CPST I can write the solution. Let us see that. Yes, after writing the given, in this trapezium AB is parallel to CD and AC and BD are diagonals intersecting at O. Required to prove is this as given in the question. Here, by seeing this ratio, we want triangle AOB and triangle COD to be similar. So these two angles are equal. AOB and COD, vertically opposite angles, are equal, and this angle is equal to this angle. Alternate interior angles are equal. This angle is equal to this angle because these two lines are parallel. Alternate interior angles are equal. These two triangles are similar by AA similarity criterion. Hence, by CPST, what we can write here is the ratio OA by OC is equal to OB by OD, but this ratio is not given. We need to prove OA by OB, so I can reshuffle this after by taking CPST. So OB is taken here, OC is taken here. Reshuffling, transforming to give the answer. I hope you understood this solution. Let us go to the next question. Yes, here's the question. In this question in figure 6.36, okay, number QR by QS is equal to QT by PR, and this angle 1 and angle 2 in the figure is equal. We need to prove these two triangles are similar. Triangle PQS, PQS, and triangle TQR, TQR. So let us do this. Now let us discuss orally. What is given? QR by QS. QR by QS is equal to QT by PR. QT by PR. If we are taking these two triangles, the corresponding sides will be PQ, not PR, but he has given PR. If we keenly observe in this figure, PQR, angle 1 is equal to angle 2, it means the triangle is isosceles. So I, instead of because isosceles, two sides will be equal, PQ is equal to PR. Instead of PR, if I write PQ in this ratio, these two triangles, two sides will become in same ratio. Moreover, this angle 1 is common in both the triangles. These two triangles are similar by S similarity criterion. Let us see how to write this answer. Yes, let us discuss what we discussed earlier in written part. Required to prove is this one. In triangle PQR, what is given? Angle 1 is angle 2, and that implies this triangle PQR is isosceles. PQ is equal to PR. So what was given? QR by QS is equal to QT by PR. Instead of PR, we have written PQ. Now in this triangle PQS and TQR, which we need to prove as similar, this ratio, corresponding sides ratio, is equal. Two sides are in same ratio, and angle 1, if you see here, this angle 1 is same, common in triangle PQS as well as triangle TQR. That implies these two triangles are similar by SAS similarity criterion. That's all. This is the solution for this particular question. Let us take a next question. Here is the question number 5. S and T are points on side PR and QR of triangle such that angle P is equal to angle RTS. Show that triangle RPQ is similar to RTS. Let us draw the diagram for this one. When we read the question, it was a little tricky whether we will be able to solve or not. When we drew the diagram, the question is like this: triangle PQR in such a way that this angle P is equal to angle RTS. In the question, it was mentioned that S and T are the points on PR and QR. So S and T, side PR and QR. On the side PR, S is taken. On the side QR, T is taken. Then what we need to do? We need to prove the triangle RPQ. RPQ is similar to triangle RTS. How can we do this? This angle is equal to this angle. Given one angle we got. This R is telling me whether this R is common in both the triangles. Yes, if you see, this angle is common in both the triangles. So these two triangles are similar. But writing in order is very important. Write the first letter where the common angle is there. Then given equal angle. RTS is similar to triangle RPQ, and that is very simple to write. In these two triangles, this angle is equal to this angle. This angle is common in both triangles, so these two triangles are similar by AA similarity criterion. Come on, this is the solution for this. That's all. Simple. Given in these two triangles, angle R is equal to angle R common, angle RTS is equal to angle RPQ. Then these two triangles are similar by AA. Writing order is important. So I hope you understood. As we are moving from ABC, a 2 centimeter side to 2.5 centimeter side, its corresponding in this triangle will be 4 and 5. So we have to go from 4 to 5 because 2's proportional side is here 4, 2.5's proportional side is 5. So we have to move from in this way QRP. So triangle ABC is similar to triangle QRP will be the answer. Let us take next one. We got a triangle. Again, third question. L, M, N, D, E, F. Okay. 2's corresponding, it can be 4. 3's corresponding can be 6 because it's a double. 2 also, two sides are in same proportion. But 2.7's double will be 5.4. We are having only 5. These two triangles are not similar because the sides are not in the same ratio. Let us discuss this question here. Fourth one, 2.5 exactly double or triple sometimes. If we are doing again, okay, correct. Sorry. 5 I am having an exactly double of 5 is 10, so they can become corresponding. Now the including side of these two is 70 angle. Yes, it's correct. So these two triangles are similar by SAS similarity criterion. So let us. So which triangle? So if these two triangles are not similar, let us write the names of this triangle. Triangle NML is similar to triangle. So writing in order is very important. NM, I am going from 2.5 to 5. So we have to go from here like this. Here P, Q, R, side is P. So P, 5, 2.5's corresponding side to angle, then corresponding side of 5. N, M, L, 2.5 M. So P, Q, R by SAS criterion. Yes. Let us take another one. Yes, in this triangle we got a 2 sides, but including angle is not 80. It is some other angle. Here the 2 sides are there, including angle is 80. So these two triangles are not similar because SAS similarity criterion is not fit here, because 2 sides including angle must be equal. As we got a 2 sides here, including angle is given 80, but here this is not including angle. Including angle is this one. So these two triangles are not similar. If you check here, one angle is 70, one angle is 80. If you cross check here 80 and 30, if we apply angle sum property, 80 plus 70 is 150. If I subtract from 180, I'll get this as 30. Yes, if you now check it out, 80 and 30, yes, two angles are similar. It means that these two triangles are similar by AA similarity criterion. Yes. So I hope you understood. Let us take some more questions. We got a question in figure 6.35. As we are doing this is exercise problem orally, if I explain, you please try to do this, or otherwise if after the explanation I'll show my answer. In figure 6.35 means this is a figure. Triangle ODC is similar to triangle OBA, and this is information angles are given. We have to find angle DOC and DCO or AB. All the angles we can find because already these two triangles are similar. We can apply CPST. Here we need to find angle DOC, DCO and OAB. We have to use all our basics and similarity criterion, CPST also. Corresponding parts of similar triangles will be used here. Now in figure, when we are finding DOC angle, if we keenly observe DOC and COB, they are linear pair, means they are straight, making a straight line. If we add, we have to get 180. That property we can use and find DOC. So simple to find this one. So we bought this angle DOC with linear pair. Then angle DCO by angle sum property also you can find, or otherwise you can find with the help of external angle property of the triangle. So we found by external angle property, we got that as 55, and okay, angle DOC also 55 we got with the help of angle sum, linear pair. Now angle OAB is equal to angle DCO. Why we got it? Because as we proved that ODC is triangle similar to triangle OBA by CPST, we got these two angles equal, so we got that as 55 from equation number 1. Hence, let us take another question. So we got a question here. What does the question tell? Diagonals AC and BD of a trapezium ABCD with AB parallel DC intersect each other at point O. Using similarity criterion for two triangles, show that these two OA by OC is equal to OB by OD. Let us do this diagram first. For this question, this will be the diagram. AB and CD are parallel. Moreover, the diagonals intersect at point O. We need to prove that OA by OC is equal to OB by OD. If we keenly observe, these are becoming the sides of the triangle AOB and COD. Whether if I am able to prove these two triangles are similar, then my problem is completed. By CPST I can write that ratio. So whenever he tells us to prove the ratio, please check it out whether this ratio forms what angle and what triangles, and whether I am able to prove these two triangles similar. So if I keenly observe, I got these two triangles can be proven similar by CPST. I can write the solution. Let us see that. Yes, after writing the given, in this trapezium AB is parallel to CD and AC and BD are diagonals intersecting at O. Required to prove is this as given in the question. Here, by seeing this ratio, we want triangle AOB and triangle COD to be similar. So these two angles are equal. AOB and COD, vertically opposite angles, are equal, and this angle is equal to this angle. Alternate interior angles are equal. This angle is equal to this angle because these two lines are parallel. Alternate interior angles are equal. These two triangles are similar by AA similarity criterion. Hence, by CPST, what we can write here is the ratio OA by OC is equal to OB by OD, but this ratio is not given. We need to prove OA by OB, so I can reshuffle this after by taking CPST. So OB is taken here, OC is taken here. Reshuffling has proven to give the answer. I hope you understood this solution. Let us go to the next question. Yes, here's the question. In this question in figure 6.36, okay, number QR by QS is equal to QT by PR, and this angle 1 and angle 2 in the figure is equal. We need to prove these two triangles are similar. Triangle PQS, PQS, and triangle TQR, TQR. So let us do this. Now let us discuss orally. What is given? QR by QS. QR by QS is equal to QT by PR. QT by PR. If we are taking these two triangles, the corresponding sides will be PQ, not PR, but he has given PR. If we keenly observe in this figure, PQR, angle 1 is equal to angle 2, it means the triangle is isosceles. So I, instead of because isosceles, two sides will be equal, PQ is equal to PR. Instead of PR, if I write PQ in this ratio, these two triangles, two sides will become in same ratio. Moreover, this angle 1 is common in both the triangles. These two triangles are similar by S similarity criterion. Let us see how to write this answer. Yes, let us discuss what we discussed earlier in written part. Required to prove is this one. In triangle PQR, what is given? Angle 1 is angle 2, and that implies this triangle PQR is isosceles. PQ is equal to PR. So what was given? QR by QS equal to QT by PR. Instead of PR, we have written PQ. Now in this triangle PQS and TQR, which we need to prove as similar, this ratio, corresponding sides ratio, is equal. Two sides are in same ratio, and angle 1, if you see here, this angle 1 is same, common in triangle PQS as well as triangle TQR. That implies these two triangles are similar by SAS similarity criterion. That's all. This is a solution for this particular question. Let us take a next question. Here is the question number 5. S and T are points on side PR and QR of triangle such that angle P is equal to angle RTS. Show that triangle RPQ is similar to RTS. Let us draw the diagram for this one. When we read the question, it was a little tricky whether we will be able to solve or not. When we drew the diagram, the question is like this: triangle PQR in such a way that this angle P is equal to angle RTS. In the question it was mentioned that S and T are the points on PR and QR. So S and T, side PR and QR. On the side PR, S is taken. On the side QR, T is taken. Then what we need to do? We need to prove the triangle RPQ is similar to triangle RTS. How can we do this? This angle is equal to this angle. Given one angle we got. This R is telling me whether this R is common in both the triangles. Yes, if you see this angle is common in both the triangles. So these two triangles are similar. But writing in order is very important. Write the first letter where the common angle is there. Then given equal angle. RTS is similar to triangle RPQ, and that is very simple to write. In these two triangles, this angle is equal to this angle. This angle is common in both triangles, so these two triangles are similar by AA similarity criterion. Come on, this is the solution for this. That's all. Simple. Given in these two triangles, angle R is equal to angle R common. Angle RTS is equal to angle RPQ. Given these two triangles are similar by AA. Writing order is important. So I hope you understood. Welcome. We got a sixth question here of exercise 6.3. In triangle ABE and triangle ACD, show that triangle ADE is similar to triangle ABC. When we got information of two triangles to be congruent, what we can take from that? Corresponding parts are equal, corresponding angles will be equal, corresponding sides will also be equal. So from that we have to bring some information and we need to prove. So what we are getting now when I am seeing these figures, that is, as we got a triangle ABE and triangle ACD as congruent, we'll get information about AD is equal to AE and AB is equal to AC. That's equal sides ratios will also be equal. Then angle A is common in both triangles, so these two triangles will become congruent by SAS similarity criterion. So let us see how the solution will be. Let us discuss what we have orally done is written part here. In triangle ABE, congruent to triangle ACD was given. From that, by CPCT, corresponding sides are equal. AB is equal to AC and AD is equal to AE. We have divided this to got this ratio because these ratios are the corresponding size ratio of the triangle ADE and triangle ABC. When we take these two triangles, we got these two sides are in same ratio and angle A, which is common in both the triangles. This is the M. Therefore, these two triangles are similar by SAS similarity criterion, and hence we have got the solution. I hope you understood. Let us take another question of this. Yeah. In triangle 6.38, okay, altitudes AD and CE of triangle ABC intersect each other at point B. We need to prove these many triangles are similar. If I am able to prove one, and the same criterion we can use for the others. Let's see triangle AEB, similar triangle CDB, AEP, CDP, whether one angle is 90 degree or not. Yes, one angle is 90. One angle we got equal. One more angle you may get either by common or otherwise by opposite angles or your basics. If you keenly observe these two triangles, angle CPD is equal to EPA. These angles are vertically opposite angles. So these two triangles are similar by AA similarity criterion. Yes, and if you take another triangles, Either you will get one angle 90 degree which is equal, another angle you may get by common or by vertically opposite. So let us write the solution for this one. See here the solution. As we got these two triangles to prove similar angle, what I discussed everything. AEP is equal to CDP 90 degree. Angle APE is equal to CPD, vertically opposite angles. Two angles in these two triangles similar, equal, these two triangles. Welcome. Here triangles, right angle at B and M respectively. Okay. Triangle ABC similar triangle AMP. ABC similar AMP. The name itself is very clear and simple answer that in these two right angle triangles, one angle is 90 degree, we got equal. Another, the starting letter tells that angle A is common in both the triangles. So these two triangles are similar by AA similarity criterions. After writing that similarity, whether with the help of CPST we get this solution or not, you can check it out. CA divided by PA, yes, is equal to BC divided by MP. Yes, by CPST we can write this answer. Because two similar triangles will have corresponding sides in the same ratio, corresponding angles are equal. This is the corresponding sides in same ratio. Whatever we discussed orally, let's write that on this. See the written part, we need to prove triangle ABC and triangle AMP similar and this ratio to be same. If we keenly observe triangle ABC and AMP, BAC angle is equal to MAP angle, BAC C and A and MAP. This angle is common in both the triangles. Triangle ABC is equal to angle AMP. 90 degree given. These two triangles are similar by AA similarity criterion, by CPST directly. If you see CA divided by PA is equal to BC divided by MP, corresponding sides are in same ratio, hence we got the solution. Let us see the next one. Got a question here. CD and GH are respectively the bisectors of angle ACB and EGF such that D and H lie on side AB and FE of triangle ABC and EFG respectively. If triangle ABC is similar to triangle FEG, show that. Let us understand this with the help of diagram. As we read the question, now with drawing the diagram, let us read the question once again. So is equal to AC by FG. If we keenly observe in this figure, CD, GH, AC and FG constitute this triangle. Whether we are able to prove these two triangles similar? Yes. How? This angle is equal to this angle which is intended given. Because the bigger triangles are similar, the corresponding parts will be angles will be equal and corresponding sides will be same ratio, so corresponding angles information is written here. So we got these two angles equal. This half of bigger equals angles are equal because CD and GH are angle bisectors. So the solution starts here. Now this all were given, just we need to prove this. Let's write the solution for that. Yes, so in order to prove this ratio, we are proving the two triangles constituting these sides are similar, then by CPST we are writing these ratios are same. So CDGH, CDGH and ACFG, this hint as the triangle CAD is to be proved triangle GFH. So we proved that, and after proving we just wrote CPST. How did we prove? One angle already equal. This is the bigger angle ACB and FGE are equal as given, but half of equals are equal. Why we are doing half? Because CD is making exact half of these angles. So same how we proved the above triangles to be similar, the below triangles can also be proven similar, because this angle B and angle E are equal, and instead of taking half of bigger, this half can also be taken and we can prove this triangle BDC and EHG to be similar. So if you see, keenly observe, three proofs are to be done. In order to prove that, we already have to do this triangle is similar, and from that CPST we have taken that, and this one as we have to done this one, the triangles similarly we can prove the below triangles to be similar. I hope you understood this problem. So problem number 10 here of similar triangles complete. Let us take a new question. Here is a question. Let us increase the size. In this figure, E is the point on side CB produced of an isosceles triangle ABC with AB is equal to AC. If AD is perpendicular to BC, okay, EF is perpendicular to AC, okay. Prove that triangle ABD and triangle ECF are similar. In order to prove this, how can we prove? Let us just think of it. So orally, if you think here, triangle ABD and triangle ECF, both triangles are similar because one angle we got 90 degree, ABDD angle, ECF angle F, they both are 91 angle we got. When we are talking about ABD and ECF, this angle B and this angle C, they both are equal because the triangle ABC is an isosceles triangle given. So two angles in these triangles are equal. These two triangles are similar. Just we need to write the proof of this now. Let us understand the proof which is written here. In triangle ABD and triangle ECF, ABD angle and ECF are equal because the triangle ABC is isosceles. These two angles are equal, and when these two angles are equal, ABD or ABC, we can name it however ACD, or otherwise we can call this angle ACD as ECA or F also. Just we have changed the nomenclature of these equal angles and we wrote here, and another two angles are equal to 90 degree which is given. These two angles are similar by AA similarity criterion, hence the solution. Let's just take the next question of here. Yes, let us understand the question for this one. What does this question tell us? Side AB and BC. Let us understand this with the help of diagram. Side AB, BC and median AD. Side AB, BC and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of triangle PQR. Okay, show the triangle ABC is similar to triangle PQR. So let us solve this question. In order to prove that, let us discuss orally how to do this. In triangle ABC, PQR, AB and PQ, BC and QR are proportional. Moreover, AD and PM, they are all proportional, which is given. So how to prove the triangle ABC and triangle PQR are similar? One thing, let us do it. We can prove triangle ABD and PQM similar with SSS similarity criterion. How? AB by PQ is equal to BC by QR. BC by QR can also be written half BC by half QR. Half BC and half QR can be changed with BD by QM because AD and PM are medians. They divide the opposite side into equal halves. Now AD by PM is also proportional. So these two triangles are similar by SSS similarity criterion. Then by CPST we can write angle ABD is equal to angle PQM. This angle is equal. Now let us go back to triangle ABC and triangle PQR. AB by PQ is equal to BC by QR, which is given. Then angle B and angle Q, which is included angle, and it is equal. Just we prove that these two triangles are going to be similar with the help of SAS similarity criterion. What I have discussed, I will write now to show you. Discussing the solution for this. What is given? This triangle AB by PQ is equal to BC by QR is equal to AD by PM, which is written here, and we need to prove triangle ABC is to be similar to triangle PQR. Also given that AD and PM are medians. From the medians, the given can be half BC is equal to BD is equal to CD. Similarly, half QR can be QM is equal to MR. Now in triangle ABC and triangle PQR, or the in triangle ABD and PQM, this triangle we are considering AB by PQ given ratio, but BC by QR can be written as half BC by half QR and BD by PM. So we got a triangle ABD is similar to triangle PQM by Triple Similarity Criterion. By CPST we can write these angles are equal. When these angles are equal, now when we are taking triangle bigger, triangle ABC and PQR, AB by PQ is equal to BC by QR, one ratio of two sides are proportional, then including angle will become what just we proved the angle to be equal. Then these two triangles are similar by SAS similarity criterion, hence we proved the solution. I hope you understood. So this is the procedure how we have to do. Okay, let us take next one. We got a question here, side AB and BC, AB, BC and median, the same question again. So let us take this question. D is a point on the side BC of a triangle ABC such that a angle ADC and BAC equal. Show that CA square is equal to CBCD. Let us draw the diagram for this. Now let us read the question once again. D is a point on side BC. D is okay, such that angle ADC is equal to BAC. Show that CA square is equal to CBCD. Whenever this type of multiplication of the sides is given, so can we able to make them a ratio? Okay, so CA square is equal to CBCD. CA square can be CA times CA, and I am transposing this to other side to get CA by CB is equal to CD by CA. Because if I prove some two triangles are similar, and then by CPST if I take the ratios are proportional, sides are proportional, then I will get this type of ratios from that cross multiplication to get this one. So if we want to prove this, which sides makes what triangle, let us see, CA and CB, CD now and CA. It means that this smaller triangle and the bigger triangle I will need to prove similar, then I will get this one. Then when I get this one, I can write this and this. How can I prove these two triangles to be similar, this smaller and the bigger? Okay, so this angle is common in bigger and the smaller triangle. Okay, then when we are talking about this smaller triangle, CDA angle is equal to CAB angle. These two angles are equal. These two triangles are similar by AA similarity criterion, what I have shown orally. Let us write that. So the solution, in triangle CDA and CAB, taking the triangles in order is very important. Already by taking CDA, I have taken C, which is a common side angle in both C, then CDA, CAB, where CDA angle, CAB angle is equal. So when we take in order, we'll get correct answers. So angle C is angle C common, angle CDA is equal to CAB, which is given. These two triangles are similar by AA similarity criterion. When we take write these two triangles in good order, we get CPST answer very correctly. See here, CA by CB corresponding sides is equal to CD by CA corresponding side. Cross multiplication, we got the solution. Hence we got the solution. Let us take the next question. We got a question here, side AB, AC and median area of triangle ABC are respectively proportional to side PQ and PR and median. Let us discuss this with the help of diagram. Let us understand the question first. What is given? AB, AC, these two sides, and the median AD is correspond respectively proportional to side PQ, PR and PM. In the previous one more type of question we have done, where AB and BC and AD was proportional to the another triangle, but here AB, PQ, AC and PR. So when this type of question is given, it is very crucial, two sides and the median which is going from the two sides. So in order to do that, we have to do little construction. So let us understand what type of construction we are doing. We are producing AD to DE such that AD is equal to DE. Similarly, here PM is produced to S such that PM is equal to MS, and already these two parts are equal because PM is median, it divides two sides. Orally, let us discuss how to do this problem in triangle ADB and EDC. When we consider these two triangles are going to be congruent because AD is equal to DE, BD is equal to DC, vertically opposite angles are equal. These two triangles are congruent by SAS congruency rule. By Cbse, AB is equal to EC. Similarly, we can prove triangle ADC is congruent to triangle BDE. By Cp-CT, we can write AC is equal to BE. Similarly, what we have done here also we can prove in the similar manner only. Now, when we consider triangle ABE and triangle PQS, AB by PQ is equal to AC by PR was there, but now instead of AC by PR we can write BE by QS is equal to AD by PM was there. Instead of AD by PM we can write 2AD by 2PM, that is AE by PS. Then triangle ABE will become congruent to triangle PQS. By CBCT we can write this angle is equal to this angle. And similarly, what we have proved, if we are taking the right side, we can prove that this angle is equal to this angle by proving triangle ACE is equal to triangle P similar to triangle PRS. Then, so here also I have done mistake by telling congruency, that is triangle ABE will be similar to triangle PQS. Then by CPST we will get this angle is equal to this angle, and similarly we will get this angle is equal to this angle. When equals are added to equals, the results will be equal, so bigger angles we got equal. Now triangle ABC and triangle PQR, AB by PQ is equal to AC by PR. Two sides are in same ratio and including angle will be equal. These two triangles will become similar by SAS similarity criterion. So long proof for this, whatever we have discussed, let us write. What I have discussed is written here. That can be proved for these two triangles. Similarly for these two and these two, all are written by similarly. These results are useful to us. Now we are going to prove triangle ABE and triangle PQS are similar. So here we are proving them to be similar. This is the ratio given. That given ratios only just adjusted, multiplied by 2 divided by 2 for AD and PM, and here AC and PR is replaced by the just we proved AC is equal to BE, PR is equal to SQ. And why we are multiplying by these two means, if you see the diagram, AD is produced to DE such that ADN is equal to DE. I want, instead of AD, I want to write AE, and AD is equal to 2 times half of AE, or 2 times AD is AE. Therefore, we have converted that and we got a ratio of these triangles, all the sides in proportional. These two triangles are similar by SSS similarity criterion. By CPST we can write these two angles are equal. If you are just going to the diagram, it means this angle BAE is equal to angle QPS. Similarly, how we prove these two angles to be equal? We can prove angle CAE is equal to RPS. So here these two angles are equal. Then when we add these two equal angles, we will get the complete big top angle of the triangle. This one complete angle BAC is equal to QPR. Now consider the triangle ABC and PQR. This two sides ratio is already given, and including angle just we proved these two angles are equal, and these two triangles are similar by SAS similarity criterion. Hence the proof. It is long but it is easy. Thank you. I hope you understood. Let us take the next question. Very simple one. A vertical pole of length 6 meter and shadows 4 meter long on the ground. In the same time, a tower casts shadow 28 meter long. Find the height of the tower. So let us understand this with the help of diagram. So let us discuss this question here with the diagram. A vertical pole of 6 meters casts a shadow of 4 meters. Similarly, a tower casts shadow 28. What is the height of the tower? We don't know the angles of inclination, but the shadows are caused normally with the help of a sun or a street light which is at a very height, but this is a vertical tower, so the shadows are caused with the help of now sun, and inclination angles with the sun will be equal. So whenever we got it questions like these, two right angle triangles will be similar because one angle is 90, another angle will be inclination angle. So let us write the proof for this. When these two triangles are similar, by Cbse we can get this answer. So in the discussion, tower and pole cast shadow at the same time. Because at the same time inclination angles will be equal, these two triangles are going to be similar because of angle ABC and angle PQR is going to be 90, and angle ACB and angle PRQ are inclination angle at the same time, so to the sun will be equal. Triangle ABC is similar to triangle PQR by AA. Similarity criterion by CBST, we can write AB by PQ is equal to AC by BC by QR, and also AC by PR also, but it is not useful to us. So write all the given information. We don't know this PQ value, that is height of the tower, we have considered to be X. So transpose X to this side 28 and 4 to the other side, we'll get X as 42, and here completes the question. Let us discuss the next question of this. Here comes the question: if AD and PM are the medians of triangle ABC and triangle PQ respectively, where triangle ABC is similar to triangle PQ, prove that AB by PQ is equal to AD by PM. Understand this question with the help of diagram now. Here, if AD and PM are the medians of triangle ABC and PQ are respectively, where triangle ABC and PQ are similar already, then AB by PQ is equal to AD by PM. That is, we need to prove that the medians are also proportional to the sides. Let us prove this by proving just the triangle ADB and triangle PMQ similar. Here let us discuss in this triangle ABC and PQR, the two triangles are similar. It means AB by PQ is equal to BC by QR, which is written here. Half BC by half QR also we can write as BD by QM, as AD and PM are the medians. Median divide the opposite side into equal halves, so we can write that also. Angle B is equal to angle Q, because I am taking just angle B is equal to angle Q. Angle C is equal to angle R also there, but my intention is to prove triangle ABD and triangle PQM as similar. Now in triangle ABD and triangle PQM, if you consider the two sides are going to be in the same ratio and angle B is equal to angle Q, then what happens? The two triangles are going to be similar by similarity criterion. By CPST we get AB by PQ is equal to AD by PM, hence the solution. Let us take the next question. Here we complete our exercise and know we got a new theorem in front of us. Let us discuss that in our coming classes, that is coming next video lessons. Thank you very much. According to the statement, area of triangle ABC by area of triangle PQ are the ratios of the areas of two similar triangles is equal to square of the ratio of their corresponding sides. We need to prove this statement. Let us discuss the proof of this. Here the diagram is ABC and PQR. Construction AM is perpendicular to, that is altitudes AM and BN in Tron. When the two triangles ABC and PQ are similar, then the corresponding sides will be in same ratio. AB by PQ is equal to BC by QR is equal to AC by PR, and angle ABC is equal to PQR, and more. This angle and this angle, all are angles, all corresponding angles are equal. So now we need to prove this in triangle, smaller in triangle ABM and triangle PQN. Angle ABM is equal to angle PQN. One angle is equal, it is given here, and angle AMB is equal to PNQ. Because this is 90 degrees, they are equal. So these two triangles are similar by AA similarity criterion. By, so what I told, it is written here. By CPST, what we get here is this ratio. AB by PQ is equal to, this is AB by PQ is equal to AM by PN. Let us keep that as equation number 1. Now area of triangle ABC by area of triangle PQR is equal to half into base into height. This is base and height cross check with the diagram. And half of get cancelled. BC by QR, AM by PN is left out. AM by PN, instead of AM by PN we can write AB by PQ, and this AB by PQ from the given is equal to BC by QR, so we have changed it and we'll get BC by QR whole square, and this ratio is equal to AC by PR is equal to AB by PQ, and everywhere the squares will be. Hence the proof of this theorem. I hope you understood this. Next we need to solve some problems on this particular theorem. Thank you very much. Welcome. In this video related ratios of the areas of two similar triangles equal to square of the ratio of their corresponding sides. So example question is in front of you. The line segment XY is parallel to the side AC of triangle ABC, divides the two parts of equal areas. Find the ratio AX by AB. Let us do this problem. Orally, if we discuss this XY is parallel to AC, from that we can prove that triangle BXY is similar to triangle BAC. Okay, and the area of BXY and area of XYCA, the two parts are equal. It means BXY area will be half of ABC, and from that ratio of the areas of two similar triangles equal to square of the ratio of the corresponding side, that we apply there to get some solution. Let us see. Let us discuss. Given XY is parallel to AC and area of triangle BXY is area equal to AXYC. This second part is equal to half of BAC area, and if we are writing area of BXY by area of triangle ABC, we will get a ratio 1/2. Now we need to prove or find the value of AX by AB. In triangle BXY and triangle BAC, these two triangles are going to be similar because this angle B is equal to angle B common and BXY is equal to BAC. As these two lines are parallel, corresponding angles are equal. These two triangles are similar by AA similarity criterion. Then by the theorem of areas of two similar triangles, we can apply area of BXY by area of BAC is equal to BX by AB whole square, that is square of the ratio of the corresponding sides. So now area of BXY, area of BAC is given as 1/2, and here transposing square to the other side 1/√2, subtracting 1 because I don't want this BX, I want AX. Subtracting 1, the simplification gave me BX minus AB. ABX minus AB, if I do, I'll get minus AX left out, and if I am multiplying minus on both sides, I'll be left out with AX by AB as √2 minus 1/√2. This is your answer. If you want to keep like this, okay, otherwise rationalizing helps to get more simplified one. If rationalizing is done, it will be 2 minus √2 by 2 or 1 minus √2 by 2 as the ratio. I hope you understood the solution. Let us take the next question. Oh, we got an exercise 6.4. Yes. Now exercise 6.4 was the question is telling us in triangle ABC and triangle DEF, the areas are respectively in this ratio. If EF is equal to 15.4, find BC. Let us draw the diagram and check it out. According to the question, this much information is given, but we know that when we are having two triangles similar, the ratio of the areas of two similar triangles is equal to square of the ratio of the corresponding sides. If we use that, we will get the answer. Let us discuss the solution. As given, triangle ABC and triangle DEF are similar, and moreover the areas of ABC 64 and DEF 121 and EF is 15.4 also. As these two triangles are similar, we can write area of triangle ABC by area of triangle DEF is equal to square of their corresponding side BC by EF by the theorem of the areas of two similar triangles. Given, substituted 64 by 121 is equal to BC by 15.4. Square is transposed to get this one and simplify to get this one. Transpose to get this one. Answer is BC 11.2. Okay, let us see next question. Yeah, here is the question where diagonals of a trapezium ABCD with ABC parallel to DC intersect each other at point O. If AB is equal to 2 times CD, find the ratio of the areas of triangle AOB and COD. Let us understand the question with the help of diagram. Let us discuss this with the diagram. You got this diagram, and here AB is equal to 2 times CD. AB is parallel to CD also. Now we will want to find area of triangle AOB by COD, the ratio. Can we prove these two triangles to be similar? Yes. When we prove these two triangles to be similar, at least two angles must be equal. We got these two angles equal. Angle AOB is equal to angle COD. Vertically opposite angles are equal if you see the diagrams AOB, COD. And another angle we have taken, angle ABO is equal to CDO. Alternate interior angles are equal. These two triangles become similar by AA similarity criterion. Then by the theorem of areas of two similar triangles, we can write the ratio of two areas of AOB by area of COD is equal to square of their corresponding side AB by CD side we have taken, because in the given AB and CD certain thing is given. So instead of AB we can write 2 times CD, CD get cancelled, and at last we get the answer. I hope you understood this. Let us go to the next question. Wow. Again, in this figure, ABC and DBC are two triangles on the same base BC. Okay, BC. If AD intersect BC at O, show that area of ABC by DBC is equal to AO by DO. Okay, let us do this question. So we need to prove area of triangle ABC by area of triangle DBC is equal to AO by DO. When we do construction, we'll get that idea. Here altitudes are drawn, AM and DM. So when we draw the altitudes, we can prove triangle AOM and triangle DON as similar, and they will be similar with the help of these two angles are equal. Angle AOM is equal to DON, vertically opposite angles are equal, and AMO is equal to DNO because they are 90 degree. These two triangles are similar, then I can write AM by DN is equal to AO by DO. This result will help here. Area of triangle ABC by area of triangle DBC is equal to half into base into height. Here common base BC is there, that is why we are going in this way. Half in BC will get cancelled. AM by DN is left out from the equation 1. We can write in the place of AM by D and AO by DO, hence the solution. He wants us to prove that this is equal to this. We proved it. I hope you understood this. Let us go to the next question. If the areas of two similar triangles are equal, prove that they are congruent also. Very simple. Here these two triangles are similar as well as their areas are equal. We need to prove these two triangles are to be congruent, and when the two triangles are similar, we can write by the theorem of ratios of the similar triangles, the areas of two similar triangles go square of the ratio of their corresponding sides, and also the two triangles areas are equal. It means area of triangle ABC by area of triangle PQR will be 1. When I write this 1 here, I'll get this. Squares will be transposed to get root 1, and I'll get only 1. And if I transpose this PQ to the other side, QR to the other side, everywhere I'll get AB is equal to PQ, or BC is equal to QR, and AC is equal to PR. Now I can prove that this if all the corresponding sides are equal, these two triangles are congruent by SSS congruency rule. Hope you understood. Very simple solution. We got a next question here. D, E, and F are respectively the midpoints of side AB, BC, CF, triangle ABC. Find the ratio of the areas of the triangle DEF and triangle ABC. So here is very typical, very nice, easy question. D, E, F are the midpoints. So here, if we are using the 9th class midpoint theorem, in triangle ABC, D, E are the midpoints. So by midpoint theorem of the 9th class, we can prove that DE is parallel to AC, and DE will be DE is parallel to AC, DE is half of AC. Similarly, we can prove DF is half of BC, EF is half of AB. When we write these statements, we can get that DE by AC is 1 by 2, DF by BC is 1 by 2, EF by AB is also 1 by 2, and these two triangles will become similar by SSS similarity criterion. Now we can use the theorem of areas of two similar triangles, that is square of the ratio of the corresponding sides. We have written here, that is DE by AC, if you see here 1 by 2, square here if we apply we'll get 1 by 4. So now area of triangle DEF by area of triangle ABC is the ratio 1 by 4. I hope you understood that's question. Prove that the ratio of two similar triangles is equal to square of the ratio of the corresponding medians. Let us take this question in the next video. I say thank you very much. Welcome in this video of exercise based upon areas of similar triangles. Prove that the ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding medians. As we have learned that the theorem for the ratios of areas of two similar triangles is like this. The ratio of the areas of two similar triangles is equal to square of the ratio of the corresponding sides. We need to prove that the medians of the two similar triangles are also proportional to the sides. We need to prove. Let us do that. If we prove that, our problem completes. Here, in order to prove this, what we are using, first of all, we are using the statement itself of the ratio of the areas of two similar triangles is equal to square of the ratio of the corresponding sides we are using, and we are proving triangle ABD and triangle PQS are similar. So in order to prove triangle ABD and PQS are similar, AB by PQ is equal to BC by QR. Given because these two triangles are similar, their corresponding sides will be in same ratio. When we are dividing by multiplying dividing half BC by half QR will be equal. When we convert that half BC is BD because AD is the median. So from that we got two corresponding side ratio is same here, and including angle is equal. These two triangles are similar. Which angle is including here? Angle ABD, angle PQS is equal. So therefore these two triangles are similar by SA similarity criterion. By CPST I can write here AB by PQ is equal to AD by PS. Keep it as the equation number 1. In triangle AB, given the triangle ABC and triangle PQ are similar, by theorem of the areas of two similar triangles, what we can write? Area of triangle ABC by area of triangle PQR is equal to AB by PQ whole square. When we write AB by PQ whole square, instead of AB by PQ, I can write AD by PS also. And here we prove that ratio of the areas of two similar triangles is equal to square of the ratio of their corresponding medians. Hence the solution. Let's go to the next question. Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of equilateral triangle described on one of its diagonal. Okay, let us understand this question with the help of diagram. Now let us read the question and understand. Prove that the area of an equilateral triangle described on one side of a square. So this is the square and this is an equilateral triangle made on the side of the square is equal to half the area of equilateral triangle described on one of its diagonal. So this is one of the diagonal, and equilateral triangle described on the diagonal is this one, QBD. Side is equal to the diagonal. Here the side is equal to the side of the square. So let us prove this. Let us discuss orally how to solve this question. All the equilateral triangles are similar, and areas of equilateral triangle is equal to root 3 by 4 a square. When I get a relationship between the side of the square and diagonal, then using that in the formula of areas of the equilateral triangle and using the theorem ratios of the areas of two similar triangles, then we will be able to prove this statement. Let us do that. Let us look at the solution of this. We need to prove area of triangle DCP, that is described on the side, is equal to half the area of the equilateral triangle described on the diagonal. And from the figure, let us consider, let the side of the square be a units. Diagonal BD is equal to, by Pythagoras Theorem, and the root a square plus a square is, you will get a root 2a is the diagonal. Now area of triangle DCP by area of equilateral triangle formula root 3 by 4 a square, and area of BDQ triangle will be root 3 by 4, side of that particular equilateral triangle, that is root 2a. So a root 2 whole square. When we apply this square to both, we will get root 2 square is 2 a square. Now we are dividing first equation with second. Why we are doing? We got we want a relationship between these two. When we divide, everything cancelled, we are left out with 1 by 2. Cross transposing, we prove that area of triangle DCP is equal to half the area of triangle BDQ, hence the solution. Let us take the next question. Oh wow, ABC and BD are two equilateral triangles such that D is the midpoint of BC. Ratio of the areas of triangle ABC and BDE. Let us look at with the help of diagram. According to statement, ABC triangle, D is the midpoint. So from here we are making an equilateral triangle. So taking E here, let us consider the side is a small side is A. Then the triangle ABC side will become 2A. According to the ratios of the areas of similar triangles, area of triangle ABC by area of triangle BDE, ABC side is 2A, BDE side is A. Cancel it to get whole square. 4:1 will be the answer. Sides of two similar triangles are in the ratio 4:9. Areas of these triangles are in the ratio. Okay, so sides are in the ratio 4:9. For example, BC by QR whole square, and areas will be square of the ratio of the corresponding side. If the sides are in this ratio, areas will be squares of the ratio of the corresponding. 4 square 16 9 square 81. This will be the answer. I hope you understood and completed this exercise with the help of ratio of the areas of two similar triangles is equal to square of the ratio of their corresponding sides. Let us learn new concepts, that is Pythagoras theorem, proof of it, converse of Pythagoras theorem, and the problems of it. Thank you very much. Welcome. To prove Pythagoras theorem. What is Pythagoras theorem? In a right angle triangle. So this, for example, triangle ABC is a right angle triangle at B. The square of the hypotenuse, that is AC square here, hypotenuse, the side opposite to the 90 degrees hypotenuse, is equal to sum of the squares of other two sides. If we are writing that according to this triangle, the right Pythagoras theorem will be AC square is equal to AB square plus BC square. This is required to prove for this. The Pythagoras theorem statement tells that the AC square, that is hypotenuse square, is equal to sum of the squares of other two sides. We need to prove that in this figure. So we have constructed altitude BD on AC. With the help of this, we need to prove the statement. Here I'll show you the technique how to prove the Pythagoras theorem. What is the technique? When we are having AC square is equal to AB square plus BC square, we need to make AB square and BC square with the help of proving two triangles similar and by Cbse. So AB square, how can I prove AB square? When I am seeing AB will be in this smaller triangle as well as in the bigger triangle, so can I prove this smaller triangle and the bigger triangle similar? If you keenly observe, that smaller triangle is ADB and triangle ABC, they both are similar by AA similarity criterion. If you are seeing BC is in this smaller triangle as well as in this bigger triangle, can I prove these two triangles similar? Yes. How? By AA similarity criterion, that is written here. In triangle CDB and CBA, C is common, CDB and CBA are 90 degrees, so those two triangles are similar by AA similarity criterion. By CPST, I can write here by CPST the corresponding sides with same ratio. Three ratios you will get, but I have to take that ratio. I want to make a BC square, so BC from here is BC, so I'll write BC divided by AC, and here in the denominator I want BC. Denominator I'm writing for the right side, numerator for the this triangle, so I want in this denominator BC, because if I cross multiply I will get BC square. So if I am writing BC of this, corresponding will be CD. If I cross multiply, I'll get BC square is equal to AC times CD. Similarly, if you see, I have proved that this smaller and bigger triangle similar, ADB and ABC. Then by CPST, what I can write here, I want AB square here. So AB divided by AC is equal to, now from this triangle denominator I want AB, so AB in the denominator, AD here, AD by AB. Cross multiply, you'll get this. If you add these two equations, that's BC square plus AB square, you will get AC times CD plus AC times AD. AC is taken common. CD plus AD, if you go to the diagram, CD plus AD is exactly AC. AC plus AC times AC is AC square. Hence, BC square plus AB square is equal to AC square, or AC square is equal to AB square plus BC square. The theorem proves here. I hope you understood the theorem proof. Let us prove now converse of Pythagoras theorem. Welcome. Here is converse of Pythagoras theorem. What does converse of Pythagoras theorem tells us? In a triangle, he is not telling a right angle triangle. In a triangle, if a square of one side is equal to sum of the squares of other two sides, that is, according to this statement, AC square is equal to AB square plus BC square. If this is possible in any triangle, the angle opposite to the first side, we are talking about first side is this one, opposite to the first side, this is 90 degree, that is right angle. We need to prove this. In order to prove this particular statement, we have to do construction with the equal side, taking AB and BC equal sides to AB PQ and BC as QR, drawing another triangle with these sides but constructing a 90 degree here. We can do it. So when we are constructing a right angle triangle with these two sides, then we will be able to prove this. Orally, if we are thinking how we can prove it, by using this particular statement, and as AB and BC are equal to PQ and QR respectively, whether we are able to prove these two triangles are congruent. If we prove these two triangles are congruent by Cbse, we can write that PQR angle is equal to angle ABC. Hence we proved a triangle ABC is right at B. So let us see the proof for this. So what we have discussed, let us see in written part. We are constructing triangle PQR such that AB is equal to PQ and BC is equal to QR. Moreover, constructing triangle PQR with 90 degree angle PQR. In triangle ABC and triangle PQR, if you keenly observe, AC square is equal to AB square plus BC square is already given. When we change this AB square plus BC square plus with PQ and QR, what happens here? It will become AC square is equal to PQ square plus QR square. Then already triangle PQR is a right angle at Q, implies PQ square plus QR square is equal to PR square. If we are applying Pythagoras theorem in this triangle, because it is right angle, so PQ square plus QR square is equal to PR square. So I can change this with PR square, squares can be cancelled, AC is equal to PR. In now triangle ABC and triangle PQR, these two sides already are equal. We have done the construction in that way only, and AC is equal to PR. Just proved. Therefore, these two triangles are congruent by SSS congruency rule. By Cbse, we can write angle ABC is equal to angle PQR 90 degree. Hence proof. This is the method to prove converse of Pythagoras theorem. I hope you understood. Let us go and prove the problems on these theorems. Thank you very much. There is another in the similar triangle. This theorem tells that if a perpendicular is drawn from vertex of the right angle of a right angle triangle to the hypotenuse, then the triangle on both sides of a perpendicular are similar to the whole triangle and to each other. Let us understand this theorem with the help of diagram. If you see keenly observe this triangle, ABC is right angle at B. This angle B or vertex B is the vertex of a right angle of a right angle triangle. So this is right angle and this is a right angle triangle, and this vertex is a right angle vertex of the right angle triangle. From here, if the perpendicular is drawn to the hypotenuse, then it divides the complete right angle triangle into two parts. That is, this is a one right angle triangle, another right angle triangle, and this statement tells that this smaller right angle triangle will be similar to the bigger one, this smaller right angle triangle will be similar to the bigger one, and they both will be similar to each other. Then the triangles on the both sides of a perpendicular are similar to the whole triangle and to each other. So let us prove this statement. Yes, here in this right angle triangle ABC, BD is perpendicular to hypotenuse. According to the statement, this is the diagram. We are proving this smaller triangle to be similar with the bigger. Writing triangle ADB and ABC. Writing this order is very important. Angle A common. Then we are writing in order such that angle ADB is equal to angle ABC is equal to 90 degrees. These two angles are equal. These two triangles are similar by a similarity criterion. Similarly, if you are want to prove this below triangle and the bigger triangle, that is triangle CDB and CBA, writing in order, common angle, then going to 90 degrees. Very simple. In triangle CDB and triangle CBA, angle C is equal to angle C common, angle CDB is equal to angle CBA is 90. Then these two triangles are also similar. I am writing this in reorder. Triangle here CBA can be written as ABC by reversing writing the vertices. So I also change this CDB as BDC. So nothing will happen. When you are seeing equation 1 and 2, these two triangles are similar to the same triangle ABC and triangle ABC. It means that they must be similar to each other. Triangle ADB is similar to triangle BDC. We proved this statement. Thank you very much. Let us go to the problems now. Yes, welcome. Video lesson. We are covering all the example problems on Pythagoras Theorem of chapter Similar Triangles. So question is here. For this diagram, angle ACB is 90 degree. Okay, CD is perpendicular to AB, CD is perpendicular to AB. Okay, prove that BC square by AC square is equal to BD by AD. Let us prove this. BC square AC square. As we have a theorem, in a right angle triangle, from the vertex where the right angle is there, if we are drawing perpendicular to the hypotenuse, then the triangle is divided into two smaller triangles which are similar to each other, and they both are similar to the bigger triangle. We are having that theorem. If we use the theorem or otherwise proving the smaller similar to the bigger one, this smaller is similar to bigger one, from that this BC squares, AC squares, CPST corresponding sides will be in same ratio. We bring that and we can get the solution. Let us see the written part. We need to prove BC square by AC square is equal to BD by AD. In figure, we want to make BC square from CPST. So BDC triangle and BCA triangle we are taking, and these two triangles are similar, but either by you can write by theorem or otherwise you can prove it by a similarity criterion. Then by CPST, BC, here BC corresponding side is BA divided by, and I want BC here the down, so BD divided by BC by CPST. Corresponding sides will be in same ratio, cross multiplication to get BC square is equal to BA times BD. Then similarly, this triangle ADC and ACB will be similar either by theorem or you can prove it by a similarity criterion. Just by theorem also correct, because in a right angle triangle, if you are drawing perpendicular from the vertex angle where the right angle is there to the hypotenuse, then it is divided into two similar triangles. We have learned the theorem of the textbook. So here again, by writing CPST, AC divided by AB is equal to AD divided by AC, cross multiplication to get this one equation, and second equation is divided, because BC square by AC square we need it. When we divide this, AB and AB get cancelled, we are left out with BD by AD, hence proved. Let us go to the next question. Wow. A question is ready. A ladder is placed against a wall such that its foot is at a distance of 2.5 meter from the wall and its top reaches a window 6 meter above the ground. Find the length of the ladder. So according to the question, very simple question it is. Here he asks us that this is 2.5 and if the window is here, the ladder is reaching at 6 meters above the ground, we want just the length of the ladder, and ladder here is the hypotenuse. So applying Pythagoras theorem, we'll get the answer. As just we have to apply Pythagoras theorem to get the AC value. AC square is equal to AB square plus BC square, and AB is 6 and BC is 2.5. Squaring them, we got this one. AC square is 42.25. AC is equal to under root 42.25 is the answer 6.5. Hence the ladder length will be 6.5. Let us go to the next question. Oh wow, very interesting question. Here in this figure, AD is perpendicular to BC. Prove that AB square plus CD square, okay, is equal to BD square plus AC square. Here this angle A is not 90 degree. Let us apply, because here two right angle triangles are there, let us apply Pythagoras theorem in these both right angle triangles to get the answer. Yes, very simple proof for this one. We are having LHS to be proved at RHS. First of all, we need to make LHS statement with the help of Pythagoras theorem applying on the right angle triangles. So AB square we need, and AB square by Pythagoras theorem in triangle ABD. If I am applying AB square is equal to BD square plus AD square, I am keeping equation number 1. Similarly in triangle ADC, if I apply Pythagoras theorem, I'll get AC square is equal to AD square plus CD square, but I want here CD square. So making subject of CD square, transposing to get AC square minus AD square as equation number 2. If I add them both, I'll get AB square plus CD square, left hand side, which is given. So I have to first of all make LHS, then RHS. I'll get some terms. When I simplify, definitely I will get what is written on RHS part. So when I am adding this right hand side and right hand side, so I got this one, AD square minus AD square is getting cancelled, and I'm left out with some terms, that is BD square plus AC square, which is RHS. Hence we got it proof. So whenever this type of statements comes, we have to make LHS with the help of Pythagoras theorem applying on the right angle triangles. Then right hand side, some equations you will get when you are simplifying that, adding and subtracting something will get cancelled, and RHS will be left out. Thank you very much. Let us go to the next question. Yes, again very interesting question is here. BL and CM are medians of a triangle ABC, right angle at A. Moreover, we need to prove 4BL square plus CM square is equal to 5BC square. Here also I am telling you, make a left hand side, then automatically you will get a right hand side. Or otherwise you make a right hand side, that is one term, and you convert it into LHS. That also works. Let us go in a straight way, that is taking LHS, simplifying to get RHS. As discussed, I have to make this statement LHS with the help of Pythagoras theorem. BL square, BL is here. If I apply Pythagoras theorem in this triangle BAL, I'll get BL square is equal to BA square plus AL square. I got this one, equation number 1. Similarly, CM square I need. CM is the hypotenuse of this triangle. So I'll apply Pythagoras theorem in this triangle. CM square is equal to AM square plus AC square. Now what I have to do? To get this one, I have to add, but 4 I don't get. Let us simplify that. Maybe 4 I'll get from right hand side after transposing. Okay, so when I have added, I got LHS, but RHS is seem to be very big. So let us apply some techniques to get our BC. So AB square plus AC square you will get as a BC, okay, Pythagoras theorem. Then AL and AC already written as, AL can be written as half AC, AM is half AB. Let us apply this and simplify to get. So when we apply in the place of AL half AC, in the place of AM half AB, in this statement we got this one. So when we square this, I got this AC square by 4, AB square by 4, AC and AC. AB square plus AC square, if you keenly observe in the right angle triangle at A, AC square plus AB square will be BC square by Pythagoras theorem. And here if I take the denominator common for, and in the numerator again I will get AB square plus AC square, that is also BC square. I am taking LCM and cross multiplying, simplifying to get here 4BC square plus 4BC square is 5BC square. I got 4 4 in the denominator. I can transpose here, and I got a statement which we need to prove. 4 times bl square plus cm square is equal to 5bc square. Yes, we got this statement. I hope you understood. What is the technique? Take LHS, bring this LHS term with the help of Pythagoras theorem, and RHS by simplifying those terms only you will get. Let us take next question. Yes. Here is the O is any point inside a rectangle ABCD. Prove that OB square plus OD square is equal to OA square plus OC square. We need to make these LHS with the help of Pythagoras theorem. Whatever the RHS terms you are getting, you will simplify to get the answer. Let us see the statement now. So, applying Pythagoras theorem to get LHS, OB square plus OD square. So OB square, I can get OB square in this right angle triangle by Pythagoras theorem. So OB square is equal to PB square plus OP square, equation number 1, applying Pythagoras theorem. Why here 90 degree? Yes, in a right angle triangle, if you draw a parallel line to any one side, it will be perpendicular to the other side, because all the opposite sides are parallel and they are perpendicular to adjacent sides. Well, we are making OD square in this. Where is OD? OD is here, so right angle triangle here. We can apply Pythagoras theorem and get OD square from here. OD square is equal to OQ square plus DQ square. Okay. And when we add them, LHS is broad but RHS is very very big. No problem. Little simplification will serve the purpose. What is that? If you keenly observe, PB can be written as QC and DQ written as AB, because this is also rectangle, opposite sides are equal, we can change them. When we change this QC and OQ, I have written again in the bracket so that keenly observe QC square plus OQ square by Pythagoras theorem. QC square plus OQ square by Pythagoras theorem applies, it will become OC square. Similarly, AP square plus OP square, OA square. Hence we got the solution. Why? What we are doing here, and this is by Pythagoras theorem. Hence we got the solution. Thank you very much. Here we complete example problems. We are starting our exercise problems here. So I would like you to be very energetic to solve the problems of exercise 6.5 that will be solved in the coming video lesson. Thank you very much. Welcome. We are 6.5, which is completely based upon Pythagoras theorem. Number 1 question tells us sides of triangles are given below. Determine which of them are right angle triangle sides. In case of a right angle, then what is the hypotenuse? If it is Pythagoras theorem is applicable, then it is a sides of a right angle triangle, and the bigger longest one will be the hypotenuse. For example, for instance, if we are applying squaring, the sum of the squares of two sides should be equal to the square of the third side. 7 square is 49, 24 square is going to be 576. If I am adding them, 7 square plus 24 square, I am getting 49 plus 576 is equal to 625, which is 25 square. So I am getting this completely. The Pythagoras theorem is applicable here, and the longest side will be the hypotenuse. Hope you understood. You can do in the similar way the below 3 questions. Triangle PQR is a right angle triangle at P, and M is a point on QR such that PM perpendicular to QR. Show that PM square is equal to QM times MR. Let us draw the diagram for this one. Now when understanding the question with this diagram, PQR is a right angle triangle, PQR right angle at P, so here is the 90 degree. Okay, M is a point on QR such that PM is perpendicular to QR. Show that PM square is equal to QM times MR. Okay, let us do this question. So orally, if we discuss PM square, PM is in this right angle also, in this right angle also, and we need the right hand side, the sides are QM and MR, which are in both the right angles. So we have to apply Pythagoras theorem in both, and let us see what is going to happen now. So very simple, we want PM square by Pythagoras theorem. PM square in this triangle, PM cube, PM square, I don't get hypotenuse square minus this side square. So PQ square is equal to MQ square plus PM square. I want subject PM because LHS is PM. So PM square is equal to PQ square minus MQ square. Then what happens? Equation number 1. Similarly, in this triangle, in triangle PMR, Pythagoras theorem, PM square will be PR square minus MR square. So what we need to do here, add them. After adding, you can clearly absorb PQ square plus PR square minus MQ square minus MR square. PQ square plus PR square in the diagram is again by Pythagoras theorem is going to become QR square. QR, when I am writing, I can resolve into two parts, QM plus MR. That's all. When I write QM plus, yes, QR, this is QR, I'm sorry. Okay, when we are writing QR in the two parts, that is MQ plus MR, A plus B whole square, when we are expanding, I'll get this one, and all these two terms are going to cancel. Left out portion is this one only, cancel it to get the answer. That's all. I hope you understood this type of solution where we need to prove with the help of Pythagoras theorem. Let us go to the next question. Wow, here in triangle ABD is a right angle triangle at A and AC is perpendicular to BD. Show that AB square is equal to BC times BD. So when BC times BD is coming, smaller and bigger triangle can be proven to be similar, and we can get that answer. And previous question also can be done in that way also. Let us do this question with the help of similar triangles. Coming to the next question, second one, AC square is equal to BC times DC. AC square is equal to BC times CD. This can be proved with the help of Pythagoras theorem, applying in both the triangles, which we have done similar type question in the just below second question. But we need to prove here, we want another proof that is applying the theorem, that is, if a perpendicular is drawn to the hypotenuse from the vertex where the right angle is, it divides the two triangles which are similar to each other. So we are using the theorem and directly writing the proof of this. So which triangle is similar? See here. So here is the solution for this. Let us discuss. In this first, AB square is equal to BC times BD. AB square is BC times BD. So we need to prove triangle BCA and BAD as similar. So they are similar with the help of a similarity criterion, or also by the theorem of altitudes of right angle triangle. Yes. So after writing these corresponding sides in the same ratio, we'll get the cross multiplication to get the answer. Similarly, in this triangle, ACB is similar to triangle DCA by the theorems of altitudes of right angle triangle. And when we write them in order, the corresponding sides in the same ratio, we get the solution for this. If we keenly observe, the third bit is exactly same like first, just we need to prove here this smaller triangle and the bigger triangle to be similar. So if we are able to prove triangle, or just write the order by the theorem, that's triangle DCA and DAB similar, you will get this statement by writing corresponding sides in the same ratio. I hope you got this answer. Let us go to the next question. Wow, very simple. ABC is an isosceles triangle, right angle at C. Okay, we need to prove that AB square is equal to AC square. So simple. As mentioned, ABC is an isosceles right angle at C. Right angle at C, isosceles, two sides are equal. If we apply here in this triangle by Pythagoras theorem, what we get here, AB square is equal to AC square plus BC square, but BC is equal to AC. Instead of BC, I want to write AC 2 times, because this is an isosceles triangle, it happens. we got the solution, hence the proof. Let us go to the next one. Yes, ABC is an isosceles triangle with AC is equal to BC. And if AB square is equal to AC square, prove that ABC is a right angle triangle. So just it is a reciprocal statement, converse statement of the previous one. Let us discuss with the help of the diagram. According to the given question, if we are writing the given AB square is equal to AC square and AC is equal to BC. Okay, in triangle ABC, AB square is equal to AC square. I can write instead of 2AC square, AC square plus AC square. And if we are writing AC square plus instead of AC 1, I can write a BC. And now if we are seeing this statement, it is just a Pythagoras theorem, converse of Pythagoras theorem can be used and we can prove the statement. That implies by converse of Pythagoras theorem, because AB square hypotenuse square is equal to sum of the squares of the two sides, it means by converse of Pythagoras theorem it should be right angle at opposite to hypotenuse, that is at C. Hence we prove that this triangle is right angle triangle. Let us take the next question. ABC is an equilateral triangle of side 2A. Find each of its altitude. According to the statement, ABC is an equilateral triangle of side 2A. So we have drawn equilateral triangle of side 2A, and this is an altitude. In this equilateral triangle, altitude, it is also the median, so it divides the BC into equal parts, A and A. If we are applying Pythagoras theorem in triangle ADB, then definitely we'll get altitude in terms of A. So we got an altitude of a equilateral triangle is equal to root 3A. We can use this as the formula of a lateral. Let us go to the next question. Prove that the sum of the squares of sides of a rhombus is equal to sum of the squares of its diagonal. Let us understand this statement with the help of diagram. Now let us understand. Prove the sum of the squares of the sides of the rhombus. It means AB square plus BC square plus CD square plus DA square. Sum of the squares is equal to the squares of its diagonal. Sum of the squares of the diagonal AC square plus BD square. We need to prove, according to the statement, AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. Whenever this type of statements we get, we have to make LHS with the help of Pythagoras theorem, and whatever we get the statement, simplify to get the RHS. Let us try this question now. Let us see this diagram. In this diagram, AB square, BC square and CD square and AD square, how we'll get by applying Pythagoras theorem in this triangle AOB, because here they are perpendicular to each other. Why? Diagonals of a rhombus are perpendicular bisectors of each other. Therefore, we can apply right angle Pythagoras theorem in triangle AOB. When we apply Pythagoras theorem in this, AB square is equal to OA square plus OB square. Here is O. Similarly, BC square, OB square plus OC square, CD square, OC square plus OD square, and AD square, OD square plus OA square. When we are adding all this, we are getting like this, and RHS is becoming like this. OA is equal to OC if we apply. OA is equal to OC. Why? Because diagonals bisect each other. O is the midpoint of AC, and similarly O is the midpoint of BD also. So we can write OB is equal to OD, OA is equal to OC. Instead of OC, I am writing OA. Instead of OD, I am writing OB. So I get a 4OA square plus 4OB square. 4 is taken in this way, 2 times OA whole square, and 2OA is exactly AC, 2 times OB is BD. And we got the solution that sum of the squares of the sides of the rhombus is equal to sum of the squares of its diagonal. Hence we prove it. Let us see the next question. Wow, this is also a very interesting question. Let us prove this in another video lesson. Thank you very much. Welcome. We are doing exercise on Pythagoras theorem. Up to problem number 7 we have covered in the previous video lesson. Here we are going to eighth problem. So problem number 8 is telling O is a point in the interior of a triangle ABC. Okay, as you are having a figure, O is the interior of the triangle. Okay, then OD, OF, OE are perpendiculars drawn from O to the sides given. Then we need to prove OA square plus, this is the statement we need to prove. In order to prove that, let us have little construction. Yes, we need to draw or join OA, OB, OC. Orally, if we think left hand side OA square, OB square, OC square, whether they are applicable with Pythagoras theorem or not. If we are rearranging them with Pythagoras theorem, whether we are getting RHS or not. Let us see. In that way, we need to prove this. Let us go to the written part. Let us discuss this in the written part. When we are taking LHS of this first equation, LHS, I am rearranging OA square plus OB square plus OC square minus OD minus OE square minus OF square was there. Rearranging, I want to write this with this, this and this and this and this. When we are seeing this statement, and in triangle ON, OF, A square minus OF square by Pythagoras theorem in triangle will become AF square. Similarly, here by Pythagoras theorem it will become BD square. Here by Pythagoras theorem it will become CF square. That is RHS. Hence we got the solution. In the similar manner, if we are taking the second equations LHS, we are applying AF square, BD square, C square, Pythagoras theorem. AF square can be written as OA square minus OF square. So when we apply Pythagoras theorem and get BD square, CE square will get like this. When we are adding, we'll be getting left hand side with LHS. Right hand side we got again the bigger equation which we got in the first solution. And how to do it? Again rearranging and reframing to get OA square minus OE square, OA square minus OE in the triangle, right angle triangle AEO, you'll get AE square by Pythagoras theorem. That's all. Hence, very simple solution, you got it here. Let us go to the next question. A ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. Let us draw the diagram for this. According to the question, the diagram is ready, and this is a ladder standing. Ladder 10 meter long reaches a window 8 meter above the ground. This is here the window, and this is the wall. Find the distance of the foot of the ladder. This is the foot of the ladder from the base of the wall. This is the base. We want this distance. This is 8. This is 10. If we keenly observe, this is a right angle triangle. We can apply Pythagoras theorem to get the BC value. Just apply Pythagoras theorem, and answer will be 6. Next question. Okay, again it's the same. A guy wire attach a vertical pole on. Okay, this is the pole. A wire is attached. Okay, 25 meter long and has its height, vertical pole of height 18 meters. Okay, and the wire is of 24. How far from the base of the pole should the stake be driven so that the wire will be taut? Again, we need this distance where this particular wire should be taut or fixed, so that this wire is taut, means tight also, and we want to find the distance between the base of the pole and the wire where it is fixed on the ground. Yes, again apply the Pythagoras theorem to get the answer. Just applying Pythagoras theorem to get the answer. Let us go to the next question. Wow. An aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another airplane leaves the same airport and flies due west at the speed of 1200 km per hour. How far apart will be the two planes after 1/2 hours? Let us draw this diagram and understand the question nicely. Let us understand precisely. He told that one plane in from the aeroplane is moving towards the north, one plane is moving towards the west. The speed of the plane which is moving towards the north is 1000 km per hour, but in 1 hour it can travel 1000 km. So in 1.5 means 1 hour 30 minutes it will travel how much? So we'll get a 1500 kilometers. Similarly, a plane which is moving towards west is moving at the speed of 1200 km per hour. So in 1 hour it can travel 1200 kilometer in 1/2 hours, it can travel 1800 kilometers. So these are the distances traveled by the airplanes in this 1/2 hours. So what is the distance between these two planes? This is the distance. AC is the distance between the two planes. As in the question he told north and west, they are perpendicular to each other, therefore this triangle is becoming a right angle triangle. And to get AC value, just apply Pythagoras theorem and find the answer. Just apply Pythagoras theorem to get AC value. AC square is equal to AB square plus BC square, and when we apply we get a big numbers. When we are getting very big numbers, here 4 zeros are there, so 100 will come outside, and 549 prime factorization gave us 3, 3 and 69, 2 3s, 1 3 will come outside, 3 and 100 multiplied 300 under root 61 will be the distance between the two aeroplanes after 1/2 hours. Let's go to the next question. Two poles of height 6 meter and 11 meters stand on a plain ground. The distance between the feet of the poles is 12 meter. Find the distance between their tops. Let us understand this question with the help of diagram. Now let us understand the question. Two poles of height 6 meter and 11 meters stand on a plain ground. If the distance between the feet of the poles is 12, find the distance between the tops. We want this distance. If we are giving names here, A, B, C, D, E, and 11 minus 6, it exactly will be 5, and this is 12. If we apply Pythagoras theorem in triangle A, B, E, you get the answer. Yes, what the answer will be? It will be 13. So distance between the tops will be 13. Pythagoras theorem, AE square is equal to AB square plus BE square, 5 square plus 12 square. Everybody knows this very simple question. Let us take a next question. And D and E are the points on the side CA and CB respectively of triangle ABC, right angle. Let's see, prove that this is equal to this. Okay, let us understand this question with the help of diagram. Now let us understand this question. D and E are the points on the side CA and CB. CA and CB are respectively of triangle ABC, right angle at C. Okay, this is a right angle triangle at C. D and E are the points. Prove that AE square plus BD square is equal to AB square plus DE square. And these type of questions are very simple. We need to just make the LHS with the help of Pythagoras theorem, RHS, by simplifying the terms which we get, will get the answer. Let us look how we get the solution. Look at the proof. In this triangle ABC, right angle at C, in triangle DCE, right angle at C, ACE, right angle at C, DCB, right angle at C. When we are applying Pythagoras theorems to get LHS, AE square is equal to AC square plus CE square. Similarly, BD square can be written as BC square plus DC square. When we are adding them, we'll get LHS of our required to prove. RHS is becoming this much, but reshuffling it, AC square plus BC square, if you are seeing in the diagram, AC square plus BC square is AB square, and CD square plus CE square is DE square. Hence, by Pythagoras theorem again applying into the RHS, we got the solution. I hope this is very simple, made, easy answer. You understood. Thank you very much. Let us go to the next question. Yeah, this is a question where the diagram is also present. The perpendicular from A, okay, on side BC of triangle ABC intersect BC at D such that DB is equal to 3CD. We need to prove that 2AB square is equal to 2AC square plus BC square. Let us do this question. As given in the question, DB is equal to 3CD. If we are writing DB is 3CD as well as CD is CD only, when we are adding them, we will get BC. Each CD value in terms of BC and this BD value in terms of BC, we got it as BC by 4 and 3BC by 4. Now, our technique is to apply Pythagoras theorem in this right angle triangle and get AB square LHS and simplifying whatever the RHS terms are there, then to get the answer. Let us see the proof of this now. Here, first step, AB square is equal to AD square plus BD square. When we see the right hand side terms, it is not equal to our RHS terms. So convert each and every side in terms of RHS terms. When you are left out with ACs and BCs, then simplify to get the answer. Just writing AD square, again in this right angle triangle by Pythagoras theorem, AC square minus CD square, BD is as it is. Now already we know that BD and CD in terms of BC CD is BC by 4 and BD is 3 BC by 4. When we applied, we got ACs and BCs. That all are the terms which we require in RHS. Just you simplify, at last you will be left out with this statement only. Now simplification part. Just simplification, we got minus BC square by 16 plus 9 BC square by 16 is, my denominators are same, so like terms you can add and subtract, so minus plus 9 is plus 8. Then cross multiplying and rearrangement to get exact the solution which we require. Hence the solution. Let us go to the next question. Yes, very interesting question is in front of you. In an equilateral triangle ABC, D is a point on side BC such that BD is equal to 1 by 3 BC. Prove that 9 AD square is equal to 7 AB square. Moreover, still we need a diagram to understand more precisely. I am drawing the diagram now. Let us understand this. An equilateral triangle ABC, D is any point on BC such that BD is equal to 1 by 3 BC. Prove that 9 AD square is equal to 7 AB square. When we are having AD like this, we cannot apply any Pythagoras theorem and get the answer. So construction, draw AE, the median, the altitude. In any equilateral triangle, median, altitude, angle bisector, everything is the same line. So AE is here, altitude as well as the median. So BE will be half BC and we want DE value because in this right triangle AED, we are going to apply Pythagoras theorem to get AD square LHS. Then whatever the RHS terms will be there, we'll get simplification to give the answer. Let's do that. Let us understand the proof. First of all, in triangle ADE, we applied Pythagoras theorem. AD square is equal to AE square plus DE square. Now again, AE square can be written as in this triangle AEB by Pythagoras theorem, AB square minus BE square, and this DE is as it is. Already we know BE and DE value in terms of BC. BE is exactly half BC and DE is 1 by 6 BC. But we know that AB is equal to BC is equal to AC because this triangle ABC is an equilateral triangle when we are converting each and everything in AB. Simplified, here we got 4 in LCM we have taken, we got it 36 minus 9 plus 28 AB square, and cross multiply to get 36 AD square, cancel, and we got the solution. Yes, this is the procedure to find the solution of this type of solution. Make LHS with the help of Pythagoras theorem. The statement automatically you will get. Thank you very much. I hope you understood. Let us go to the next question. Yes, the question is in front of you. In equilateral triangle, prove that the 3 times the square of one side is equal to 4 times the square of one of its altitudes. Let us understand this question precisely with the help of diagram. Now let us discuss this question with the help of this diagram. And an equilateral triangle, this is an equilateral triangle. We have taken equilateral triangle side as 2A. So 2A, 2A, 2A. And we need to prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. So whether it is required to take 2A, then we'll use it, otherwise we'll not use this. Let us apply Pythagoras theorem in this triangle ADB and check it out whether we are getting the solution or not. Discussing what I am writing here. In triangle ADB, Pythagoras theorem is applied and we are not using these 2 A's and A. Just we want that BD is half of BC. Instead of half BC, I can write half AB also because it is an equilateral triangle, all sides are equal. Now AB square is equal to AD square plus BD square. BD is written as half BC or half AB and transposed here to get the statement. Now simplification will give us a solution. Yes, After the simplification, 1 by 2 ab whole square, when we apply ab squared by 4, cross multiplying, we get this one. And 4ab square minus ab square is 3ab square. This 4 is transposed to other side to get 4ab square, and say we got the solution. In this way, we have proved this statement very easily, just applying by Pythagoras theorem. No need to take these a values. Okay, let us go to the next question. Okay, tick the correct answer and justify in triangle ABC. AB is equal to 6 root 3 centimeter, AC is 12 and BC is 6. The angle B is whether these sides are applied or making a Pythagorean triplet or not. If they are the sides of the right angle triangle, then we can check it out with this right angle triangle. Let us see whether Pythagoras theorem is applicable for this or not. Yes, so among them three sides, longer is 12, so AC square is equal to 144, AB square plus BC square. Longer side squares, hypotenuse square is equal to sum of the squares of other two sides, hence the opposite vertex to the hypotenuse, that is AC is hypotenuse, the opposite vertex will be B. Must be 90 degree. Yes. Wow, we have completed our exercise problems on Pythagoras theorem and as well as similar triangles. I hope you understood and enjoyed the triangles very nicely. Please take more and more questions from other textbooks like Adi Sharma or S. Chand, or take some questions from the previous year's papers and solve it to get this joy of solving analytical mathematics. Thank you very much.